Hi, I'm Jim Davis. Welcome to Research Journal. When it comes to fascinating science, nothing quite beats the disappearance of the dinosaurs. Why they died and the chain of events leading up to their extinction has tantalized children and adults for years, and the list of explanations for their demise is at least a mile long, still growing. In 1988, the theory of extinction by asteroid impact is receiving the widest acceptance by scientists, but not by all. One paleontologist, Robert Sloan, thinks that theories like the asteroid theory are a bit simplistic, and that to really understand why the dinosaurs disappeared, you have to understand a great deal about the process of extinction itself.
This is my laboratory. This is where you study problems in paleontology and extinction. You have to study them by looking at the events that happened before, during, and after the extinction and see what changed. What I see when I come out into the field like this is something more than just a place where there's an old abandoned rock quarry. What I see is ideas. Any piece of rock I pick up in this quarry has half a dozen visible fossils, let alone the ones that are too small to be seen with the naked eye. Then I take the material home to the laboratory, and in the laboratory I do the final identifications, the rock preparation, the crushing, the grinding, the polishing, the etching, whatever it takes to get the fossils and the data out of the rock. At that point, it's time for the inspiration to strike. It does strike regularly. Oh, that's a gem, a real gem. There aren't very many of these that have been found. This is only about the 20th, and you can learn an awful lot about how brains were wired among the earliest hoofed mammals just by taking a look at this small bone.
For Bob Sloan, professor of paleontology, answers to huge questions about how we got here come in very small pieces. One of the 6 major extinctions Bob has studied over his 35 years at the University of Minnesota is the Dike-Bentonite extinction. It occurred 454 million years ago when a huge volcanic eruption occurred that covered the eastern half of the United States in thick ash.
This one is important mainly because it explains a major stage boundary, a boundary between times represented by 2 different groups of fossils. It gives us a very high degree of precision. We can match up rocks of exactly the same age all over the eastern part of North America and solve many problems about the distribution of those rocks, why they are, where the sources for the rocks were, what the kind of depth of deposition was, how it varied from one place to another. This ash bed has helped us immensely in working out the geology of southeastern Minnesota.
As we look more closely at the 4-inch thick layer, keep in mind that the world looked a lot different than it does today. Minnesota was located near the equator and was deep underwater.
Down here at the very bottom of the ash bed, we have a chocolatey layer of clay shale, which is full of all the organisms that were living in the sea at the time. When this ash settled out after that eruption, which made Mount St. Helens look like a piker, the net result was that everything in the eastern half of North America died. This is the actual material that was blasted out of the volcano 1,200 miles away. The total amount of rock that came out of that volcano was 80 cubic miles. That's a cube of rock about 4.5 miles on a side. One of the bigger volcanic eruptions of all time. This did produce a very major extinction.
Certainly the most popular extinction of all time was the extinction of the dinosaur. And like most of us, Bob Sloan is fascinated by these huge creatures from the past. Unlike most of us, Bob is convinced he knows exactly how they became extinct. Not with a bang, as many noted scientists believe, but rather with a whimper, victims of a gradually changing environment, not a sudden asteroid impact.
An asteroid did hit the Earth and caused the extinction of many marine animals, much as this volcanic ash eruption caused the extinction of animals in the eastern half of the United States. But on the other hand, so far as dinosaurs are concerned, it's not a really major cause of dinosaur extinction. The extinction of dinosaurs, for example, came about as a result of a global sea level drop and temperature drop, and the introduction of some new competitors, some mammals from another continent that ate the same foods that plant-eating dinosaurs did.
A new discovery of dinosaur fossils in Alaska near the North Pole seems to support Sloan's theory.
The fact that you have dinosaurs within 2 degrees of the North Pole, even at a time when the North Pole was temperate in climate, suggests that they could manage to survive.
The fight over which theory is right will go on for a long time, as more and more scientists find and dig into our planet for answers.
You can come down on which side of the fence you want, but there's a lot of room for more research, a lot of room for questions. It's a really neat aspect of geology right now to be looking at that. It's probably one of the more exciting areas where you can combine physics, geology, geochemistry, paleontology all into one massive group and have everybody arguing and fighting out over the details and stuff like that. It really makes it kind of an interesting aspect of science.
For Bob Sloan, the most interesting and disturbing part of his work as a paleontologist is using the past to predict our future.
We're in the midst of the very biggest extinction and the fastest extinction of all of geologic time. And the real reason for this extinction is primarily the great expansion of the human species. There are countries and there are religions that think it is their duty to produce as many possible people to fill up the world. The minute they do that, all they do is kill species off. Species are going extinct more rapidly now than at any time in the past, and we are about to lose half of all the species in the world within the next century. The biggest extinction of all time was not that big.
What caused the extinction of the dinosaurs? Well, that's a familiar and a fascinating question that sort of crops up in the headlines every couple of years. It's back again. It's also the subject of our conversation for the next 25 minutes or so. And here with us to conduct that conversation is Dr. Robert Sloan. He's a professor of paleontology in the Department of Geology and Geophysics at the University of Minnesota. You've been here for a while, since about 1953, I understand.
Right.
Thank you for joining us here today. You know, there seem to be dozens and dozens of theories about what caused the extinction of the dinosaurs. Some of them are sort of silly sounding, I understand. There's one about that Freud put forth. I'd kind of like to hear about that one.
Oh, Sigmund Freud had no problem explaining the extinction of dinosaurs. He had much greater problems explaining why people did not go extinct.
What was his reasoning for the
The
extinction?
universal death wish that he had postulated.
I see. What are some of the other theories? And we have to emphasize that.
All sorts of people have proposed theories about dinosaur extinction. They involve such things as climatic changes, changes in the composition of the atmosphere, some rather wild, far-out ones that are untestable, poison gases, things of that sort. Any way you could possibly kill one animal at one time or another has been proposed as a reason for dinosaurs having gone extinct.
What is supported by data? They can't all be true.
No, they certainly are not. I've spent the last 25 years gathering data on just exactly what happened during the process of dinosaur extinction. It's a process, not an event.
Okay.
It took a long time. The things that I found going wrong during the time of dinosaur extinction were, first of all, a major global drop in temperature of about 18 degrees Fahrenheit over a 10 million year period. It continued past that, but that certainly is a major factor. There was a major drop in sea level of around 600 feet. This was enough so that the Gulf of Mexico, which had been all the way up in Alberta and North Dakota, retreated to its present position. And the effect of that was to greatly change the climate from being very uniform from summer to winter, about like Florida is today, to the kind of really wild seasonal climate we now have in the Dakotas and Minnesota.
Big difference. I mean,
very big difference. Modern Montana, the area where we go to collect these fossils, is very different than it was at the time they were living. Today, the temperatures range from 120 in the shade in the summer to 50 below in February.
it would seem almost as if that in itself was enough to cause the extinction of any given species.
Well, things do survive very nicely in Montana, even despite that range in climate. But the dinosaurs didn't last even close to that big a range.
What about
there were
this?
also changes in vegetation.
Okay.
The number of kinds of fossil plants that we see in the age of dinosaurs kept getting smaller and smaller and smaller. The kind of vegetation that you might have then would be giant strangler fig trees, breadfruit trees, palm trees of various sorts.
Very tropical.
Very, very tropical, about like modern Tampico or, say, the Gulf Coast of Louisiana and Texas. Instead of the present landscape of Montana, you did have the high mountains in the west, but in this part of Montana, the area was as flat as a pool table and looked about like the Louisiana bayou country.
Is there anything about current Montana that is left over from that time in terms of the vegetation?
The sand and the clay is still there, but that's all. Everything else has changed.
All the plants?
All the plants have changed. None of the plants that were living there then still live there now. Because of that sea level drop, there was also the introduction of some brand new groups of mammals. Okay. Dinosaurs had lived in competition with mammals throughout their whole career. But here, just a million years or so before the end of dinosaurs, with that time of sea level lowering, new kinds of mammals migrated in from Asia. And they were more efficient plant-eating mammals than any that had lived here before. So there was actually competition for the available plant tissue between the dinosaurs and the plant-eating mammals.
Competition, changes in diet, changes in climate. Quickly, because we're going to take a short break, how adaptive were dinosaurs?
Dinosaurs were exceedingly well adapted to what they lived in. They would probably get along very nicely in many parts of the world today if there were any left. If you think of a dinosaur, you have to think of a very, very active animal, as smart and aggressive as birds, much brighter and much faster running than any modern reptile. If you really want to know what a dinosaur behaved like, watch an ostrich.
Really?
Mm-hmm. Birds are essentially dinosaurs without feathers. The very first kind of dinosaur is the ancestor of birds, and most of the things that you think of as being characteristic of birds are also true for dinosaurs. They were warm-blooded, very active animals that could run very fast. Tyrannosaurus, like this thing, could run at 50 miles an hour, whereas humans can only manage 15 for short stretches.
You don't think about dinosaurs and ostriches commonly, but
no.
We're going to take a short break. We'll be right back. We want to take a paleontologist eye view of the Hell Creek formations in Montana. Stay with us. We want to talk now briefly about the work of a paleontologist. We're going to visit through videotape a dig in Montana. But before we do that, Dr. Robert Sloan, I want to ask you about this relationship between dinosaurs and birds. Now, tell me more about in what way dinosaurs are bird-like.
Well, the very first dinosaur is also the ancestor of birds. In fact, the very first bird we have on the fossil record is so much like a dinosaur that when one specimen was found with no feathers, it took 150 years for people to realize that it was really a bird and not a dinosaur.
Now, birds have nests. They tend their young.
Birds have nests, and they're warm-blooded, and they are very active animals, much more active than reptiles. Dinosaurs are like birds in that respect. You really must think about dinosaurs as featherless birds.
Really?
You think of them as ostriches that have been plucked.
Okay, okay. I
That's
can
reasonably
make that
close.
jump in my mind, I think. Your work has been in Montana over the
Yes.
years, primarily. I'm curious what you have found about the community of life that existed in the Hell Creek Formation way back then. What kind of a place was it?
Well, it was very like the modern Louisiana bayou country, flat as a pancake, with meandering streams wandering through it. The vegetation included breadfruit, palm trees, fig trees. We've got fossil figs. We've got over 93 kinds of fossil vertebrates. We've got 19 different kinds of dinosaurs, ranging from great big Tyrannosaurus with a 5-foot skull and teeth that long to elephant-sized Triceratops and duck-billed dinosaurs that were death on forests, just the way elephants
Yes.
are. All the way down to little bitty dinosaurs like this one. This is the lower jaw of one of the small meat-eating dinosaurs. It was the smartest dinosaur that ever lived. If it had not become extinct, this would have been my candidate for the animal to become the intelligent bipedal species. This thing had an opposable thumb and 2 fingers, so it
could
had a
grab
precision
things,
grip
yes.
and power grip. It was the size of an ostrich and could run just as fast. We have other middle-sized meat-eating dinosaurs like this one. You can see the steak knife-edged teeth. We've got, of course, the big plant-eating dinosaurs like Triceratops. In terms of birds, we've got stilts, sandpipers, and a little knee-high flamingo.
Again, very tropical.
Very tropical. We've got 20 or so different kinds of frogs and 20 or so kinds of lizards. We've got lots of salamanders. In terms of fish, there's fish very familiar to local people. There's the freshwater dogfish, or bowfin, that still lives in the Mississippi, Missouri today. It hasn't changed much. We have garfish, like the modern short-nosed gar, about 3 feet long, but closely related to the big alligator gar down in Louisiana. We have a sturgeon and a paddlefish, both of which still live
Yes,
in this
yes.
region today. We have a little perch, and we've got a crocodile, an alligator, and a champsosaur, which looks like a needle-nosed crocodile, all fish eaters of various sorts.
Now, you're painting the picture of a very active community.
It is a very active community. There are about 30 kinds of mammals, ranging from possums, coming in small, medium, and large size, skull size. We have multituberculate mammals.
We've
which
got
are
some
the equivalent
videotape
of-
that I think we ought to roll as we're talking
Okay.
here. We'll show you what this area looks like today. Continue, though.
We've got multituberculate mammals, which are like mice, squirrels, and woodchucks today, and did the same sorts of things. We have hedgehogs, and we have the very first hoofed mammal and the very first primate. Every one of us is descended from one of the fossils that I collected out here in these Badlands.
Now, these Badlands that we're seeing right
These
here.
Badlands right here.
Tell
in
me
fact,
how
it's
you-
named Purgatorius, after that hill you just saw.
All right.
Now
Here's one
we're
of your, groups
standing
of
in
students.
Bug Creek Anthills Quarry.
Okay.
We've prospected through the Badlands, and we found a good place to start quarrying for fossils. This is the first group of people to hit this particular quarry that year. And what I'm doing is training the kids how to collect the fossils. You really have to get your eyes down just 10 inches from the ground, or you will miss these very tiny teeth.
Now, how long will they be there like that?
They're going to be there for an hour and a half doing the hands and knees crawl across 20 feet of outcrop.
An hour and a half, 20 feet.
An hour and a half to cover 20 feet. We really want them to do this like you were cramming for a physics exam.
Yes.
Now, but the really efficient way to do it, after you've learned what these things look like, is to do what we're doing here. We're sacking up sand. We take a sample of about a ton of sand, carry it off to a place near the Fort Peck Reservoir where we can wash. We put it in screen boxes and wash the sand and the clay away from the bones. And here we are doing the
some of that,
Maytag
yes.
twist and the side-to-side slosh, trying to do anything we can
Oh, it
to get the
gets hot
sand
out
and
there,
the
doesn't
clay.
it?
Well, it's always very pleasant to be out there in the cool water. Having done the sieving and let the stuff dry, you can then look at the fossils.
Now, did you stumble upon this? How did you determine that this was an area in which to dig?
We knew that because Barnum Brown had collected hundreds of dinosaurs out there in 1902.
How did Barnum Brown figure it out?
A rancher sent a fossil into the American Museum at New York, and Barnum went out to see if it was any good. It was, and he then spent the next 6 years or so collecting dinosaurs there. We went out there specifically because there was a rich sequence of rocks with many fossils in them that spanned both sides of the extinction of dinosaurs. So we could cover both sides of this major ecological event. The gradual extinction of dinosaurs and the very rapid evolution of the hoofed mammals to replace them.
A good find.
Yes, a very good find.
We're going to take another short break, and when we come back, we'll talk about some of the impact that extinction research might have on our own future as human beings. Stay with us. We have just a couple more minutes to talk with Dr. Robert Sloan, a professor of paleontology at the University of Minnesota, about dinosaurs and the idea of their extinction. There is a theory that there was an asteroid which hit the Earth and, I suppose, created a huge cloud of dust, and that was the cause of the extinction of the dinosaurs, and almost instantaneously. Talk to me about that theory. Does it make any sense?
Partly yes, partly no. There's no doubt that the asteroid did hit. The asteroid was about 9 miles in diameter. A part of it apparently broke up before it hit. A part of it hit the town of Manson, Iowa, and blew a crater about 20 miles in diameter there, blowing sand grains and dust all over the world. The total asteroid produced a layer of dust that thick over the entire world.
How would that compare to St. Helens?
Oh, St. Helens, we were 800 miles from St. Helens, which is very close. And on the day of St. Helens eruption, we were out at Bug Creek. We got a millimeter of dust.
Big difference.
Yeah, it was enough to reduce visibility to a quarter of a mile, so we stayed indoors and played hearts all day.
All right. The big asteroid.
The big asteroid, however, did produce a layer of dust that thick all over the world. The dust stayed up in the atmosphere for 6 months or so, enough to shut off all the sun for that period of time. It did have a major impact on marine communities. Its impact on dinosaurs was very small. Let me show you why.
Okay.
Here is a graph I've drawn. This is a timeline here. This line is the time of the asteroid strike,
Okay.
a particular day. This is 10 million years before that and 10 million years after. This is the number of kinds of dinosaurs, 32 kinds of dinosaurs, 10 million years before the Cretaceous, dropping steadily until just before the impact there were 12 kinds of dinosaurs in Montana. Immediately after, 11, slowly dropping in the next 250,000 years to none in Montana. In China, they survived a little longer. In South China, they lived a full 1,000,000 years after the asteroid impact. This other line shows the first appearance and then rapid increase in the number of kinds of plant-eating mammals, and then their later decline as the temperature continued to go bad.
What's this tell you?
What it tells me is that it's not a simple problem. There are many reasons for dinosaur extinction. This part before the asteroid impact is mainly climatic. The temperature changes, perhaps the oxygen change, the major sea level change, the change in vegetation, all of these standard ecological processes. The dinosaurs went out one by one. There are probably as many reasons for dinosaur extinction as there were kinds of dinosaurs. When the first mammal appeared, first of these herbivorous mammals appeared, you had major competition between herbivorous dinosaurs and herbivorous mammals. And anyone who thinks that animals of very different size can't compete has never lived with my rancher friends through a grasshopper play.
Yes, indeed.
In any event, The final causes after the asteroid impact are mostly due to continued competition with the mammals.
Why were the dinosaurs not able to evolve?
They did. They were continuously changing all the way through this interval. It didn't help.
Apparently not.
It was one of those times when Murphy was an optimist. Everything went wrong that could possibly go wrong.
You know, the idea of extinction is a very frightening one. We hear about species threatened with extinction today, and it really tugs on the heartstrings. What have you learned or sort of, come about on your own thinking about the idea of extinction?
Well, the first thing is extinction is a very normal sort of thing. Every species is very, very likely to go extinct. However, some are going to last much longer than others. It's not always easy to tell, except with 20/20 hindsight, which ones are going to make it. Nonetheless, there are periods of time when there are more extinctions than usual. The end of the Cretaceous is one of them, and one of the very biggest of these extinctions of all of geologic time is the one that we are in right now and that we are causing.
Man.
Man. People.
Can you look ahead and...
Well, the rapidity with which this is going to take place will really depend on how big human population grows. We have gone from 1 billion people at the time of World War I to 5 billion people right now. They're a quarter of the world's people in an area of China the size of the U.S. east of the Mississippi. I didn't see any small birds. I didn't see any small squirrels. They have literally wiped out everything except that which will support people.
Dr. Sloan, we're just about out of time.
Okay.
Thank you very much for today's conversation. It's been fascinating. Thank you for joining us. And next week, we're going to take a look at a very special test, a psychological test that was created right here in Minnesota in the 1930s during the time of the Great Depression. Well, how is that test faring in the 1980s? That's next week. I'm Jim Davis. We hope to see you then for Research Journal. To order a videotape copy of this program, or if you have questions or comments, please call our viewer comment line. The number is 625-4040. Our answering machines are standing by to record your message.